Good morning, everyone. My name is Nitin. I am from Civil IT, Department of Civil Engineering. Subject is BEEE. Roll number 23011T0135. The topics given to me were earthing, types of earthing, and types of batteries. I'll be trying to go through this a little deeper and try to explain it to you in a much easier term so that it is easier for you to understand. Let's get into it. Understanding earthing, or in simpler terms, grounding. Grounding is a definition where we are trying to dissipate extra or sudden burst of energy back to ground, which is useless for the electrical circuit or the electrical transmitting wires. This is harmful for both the wires and the circuitry as it causes burns and components to burst off. The fundamental of how it works is quite simple. There's a separate wire, a neutral or a grounding wire, as there are three types of it where where the dissipation of excess energy happens directly to the ground, which in turn connects the circuitry for the fuse to activate, shutting down the system or shutting down the transmission of electricity, which helps us retain the healthiness of the electrical component. While it is a little bit harder to understand from the paragraph I've given you, as I'm trying to explain it to you, it is just easier to understand as this topic has been already done a little back in our education system. Now comes the hard part. There are three types of electrical grounding: TNS, TNCS, IIT, all three having different meanings and different methodologies. TNS is something which we use every day in our electrical components. It is used from our laptops, mobile phones, its chargers, and from TVs to fridges. TNS is something where we have two independent wires, one is neutral and one is earthing, where the neutral dissipates excess amount of energy back into the circuitry, and the grounding helps us dissipate the shock or sudden burst of electricity back to the ground. This helps us create a better electrical circuitry, which in turn again helps us have a better component life. As it has two different wires, the fuse which gets closed off is the main one, which is in our houses, or which is also known as MCBs. TNCS is where we have single wires, which at the end gets dissipated into two wires. One is neutral and again one is grounding. This helps us transport both the excess energy and the fluctuation energy in the same wire, as it is much more cheaper and easier to create and transmit, and at the end dissipates whatever is needed into whatever wire is set up for it. For example, neutral for dissemination of excess energy and grounding wire for fluctuation energy. But the wire which transmits both these excess of energy and the fluctuation energy is same. IT systems are something which is quite similar to both TNS and TNCS, but it is mainly used in hospitals and industries where components and emergency systems are supposed to run non-stop, even if there is an electrical shortage. The working principle of it is the same. It has both in neutral and grounding in one wire, or sometimes even distributed into two wires at the end. It distributes the short electricity back to the ground, but doesn't disturb the fuse. While most of the excess energy or the fluctuation gets dissipated, the electrical system continues to run. Fundamentals of battery technology. In simple terms, battery is something we use to store electricity and use it later on. Batteries are something we've been studying from our class 10th or class 9th, but it has two types of battery systems. Although the fundamentals of battery is the same, where it works on the similar principle where chemical energy is transformed into electrical energy. There are two types of battery types, or battery systems as we call it: primary and secondary. Primary are non-rechargeable AAA or AA cells which we use in our everyday life, like watches, batteries, etc., which only dissipate energy while they don't recharge themselves. They offer a longer lifespan, but they don't work for more than 2 or 3 years depending on the size of the battery. But the secondary system is where we use every day, and it's almost in every type of electrical component available. Secondary battery, or also known as popularly known as lithium-ion battery, is where we use lead or lithium-ion cells, which are rechargeable as their electrolytes or electrolyte circuit goes through a recharge and stores up energy back again, ready to dissipate it again, as it's more reusable and more better as a other form of electrical output source or power source. It is more reliable and is commonly used by everyone. There are three types of primary batteries, or the non-rechargeable batteries as we like to call it: zinc, carbon, alkaline, and lithium. Lithium is almost always known by us, as we use AAA and AA batteries mostly of lithium, while zinc, carbon, and alkaline are not so widely known. Zinc carbon is a low cost battery. It uses the zinc carbon electrolytic surface, which gives us a similar lifespan as lithium ion, but it is not that useful as its shelf life is a lot more lesser. Alkaline batteries, or high energy density batteries, they are competition to zinc batteries as they have higher output but a lower lifespan as usual, and a lower battery life, where the dissipation energy is higher, so the battery tends to drain out quicker. Lithium ion is always known by us. It has already been studied by us. So lithium ion in short terms is somewhere we use lithium ion electrolyte surface, and it is much more affordable as we have made it, and much more efficient in terms of energy. In secondary battery technology, again, lithium ion was always used as both primary and secondary due to its feasibility and manufacturing costs, while it also being useful in both types of non-rechargeable and rechargeable battery types. We'll also look into lead acid, where we use automotive batteries, and these type of industrial batteries are used mainly comprising of lead acid battery technology. They're known for their high surge current, making them ideal for uh, electrical, or what we call it as battery backup, or car batteries, which we use to start our vehicles or to make our vehicles run. They are much more costlier, but have much more lifespan as compared to lithium ion. Their recharge is also quicker, but due to its manufacturing and due to its nature of acidic, it tends to run out, or its shelf life is lot lesser. Nickel cadmium is a type of battery used in heavy industry appliances, mostly in machinery in factories, offering a longer lifespan and more performance, but they are toxic to manufacture, so its manufacturing is quite less. But in comparison to lithium ion, it gives us the similar discharge. Nickel metal hydride, or always we know it as NiCd batteries, they are less toxic, have higher energy dissipation, higher density, but they are only used in hybrid vehicles like petrol and electric vehicles, both combined into one. They are also used in power tools, and they're also used in high density electrical appliances like power drills or power tools in basic. Although battery innovations have been happening with more and more electrolytic, or what we call it as liquid state electrolytic batteries, the innovation for solid state batteries and semi solid state batteries has been going through, with solid state battery still being under development, while semi solid state battery having been produced by a competitor in China. Solid state batteries and semi solid state batteries offer much more advantages while being lesser toxic, having higher density, higher output, and higher charging capabilities, or rapid charging in easier terms. Solid state batteries, as we already have it in the definition itself, has a solid electrolyte mostly made by zinc or other types of electrolytic substances, which offer higher density, higher power output, while having more lifespan. While its disadvantage is that it doesn't quite run more than 5 to 6 years, as it is found to be having crystals after 5 or 6 year run. They're safer than lithium-ion batteries as they can be cut open and still be connected to run the circuitry, while lithium-ion tends to explode. Its safety and its reliability and efficiency is more better compared to a lithium-ion battery. A semi-solid state battery has both liquid and solid state electrolyte, which makes it a slurry kind of a electrolyte to work with. It is more heavier than solid state battery as there are two types of electrolytes packed in one, although offers the same similar benefits than the solid state batteries. Thank you.